Okay, so I think we're going to get started. So actually today we are going to start the process of actually building them, embedding the short-term memory. So let's see what we'll do today. So today I will be focusing more on the chat memory. So I'm just going to actually set up the chat memory. So so let's get started. So I'm going to start with the requirements. First, we can set up the requirements. So the requirements that we actually need, the dependencies, sorry, that we actually need for this project. So I'm going to set my requirements at txt file. Requirements txt file. And here you can specify you can actually specify the dependencies that we are going to be using. So LangChain, think Groq. Let's try LangChain Groq, then LangChain MongoDB. MongoDB, then Mongo. We're going to use MongoDB will be our database for storing those chats. So so that we're able to load environment variables. Then we also need a init for our front end interface. Then the class JSON. Then we also need data class that's supposed to be data classes JSON. Then we also need LangGraph. In yesterday we talked about checkpoint, and we saw how checkpoint is actually important when we are actually building this. When you are actually building this chat application, these are the dependencies that I actually need for this one. And I'll just I think I have the folder. So here I'm just going to check. Let me see the type of environment that I'm going to be using, so that I actually install these dependencies. So for the environments, I have this one, LangGraph. Let me activate LangGraph so that we can actually folder activate LangGraph. So that is the virtual environment that we are actually going to be using for this project. So LangGraph, then I'll just do the pip install hyphen tar, then the requirements.txt. Requirements.txt, those are the dependencies there. Requirements pip install. Okay, so I think while we are installing these dependencies, let's start if I have installed the global, I'm in the LangGraph environment. LangGraph. Let me see if I can use another. Let me try to use command prompt. Activate LangGraph. I think that's the environment. That's the environment that we're going to use. Then, if you have the LangGraph, then you can just do the pip install -r. Then we pass in the requirements.txt file. So requirements.txt, so that we're able to actually install the dependencies that we can able to install the dependencies. We can install requirements.txt. Requirements install LangChain. See. So while we are installing these dependencies, then we can start building the application itself. So let's first create a configuration file that will enable us to actually set up all the dependencies. Dependencies, that means MongoDB, using MongoDB, as well as the Groq API key. So we can set up just create a new file, then configuration. So the configuration manager. So configuration manager. So supposed to be configuration manager. Let's rename this. So configuration manager. So it's a .py file. Then I can just set up. So import OS. Then import from .env. .env. So we got that one. Then you can load the .env. Then you can set up the MongoDB configuration. So you can set MongoDB URI OS.get environment. So we need to provide our MongoDB URI in our .env file. So again, we need to create the supposed to be under the short term. So I now understand that the reason as to why we are not able to. Okay, so just create .env file. So .env file. So under .env file, we can then set up our MongoDB URI and all that. So let's finish up with this one. So MongoDB URI. Then we can just set a conditional statement so that if we miss this, if not MongoDB URI, then we are going to release MongoDB URI is not set in the environment variables. Then I'll specify the MongoDB name. So that's the name of database, the collection. Yeah? So the name of the database that we are going to be using. So MongoDB. So this is the database name. So OS MongoDB. So that's the OS.get.env. Then we're just going to specify MongoDB. That's the database name. Okay, then if not MongoDB, then that is not provided. So once we are done with this, then we can also get the Groq API key. So that we're going to set the Groq API key. So Groq API key. So configuration. We are going to set that up. So we are going to say the Groq API key. We need to provide the Groq API key in our .env file. So once we have that, but if you are missing that, then we are going to raise this error because using this, so that in case we are missing that, we are able to note where that error is actually coming from. Then it will be easier for us to actually solve that problem. So this is the configuration. Then I'll just create a new file under backend also. Or what I could have done. So we can just create a new folder and call that this folder holds the configuration details. So I just config. Then I'll replace the init underscore init. This is put file. Then I'll put the config manager under the config. I think this one is okay. Under config, again, I'll create a new file db. So say db.i. So that one is okay. Then this is the LangGraph checkpoints. LangGraph.checkpoints MongoDB. So we're going to import the MongoDB server. So MongoDB to the MongoDB server from LangGraph.checkpoint.MongoDB to the MongoDB server. Then we're just going to import the config manager. So from the config manager, we're going to import the MongoDB URI. Okay. So from config dot configuration manager. So we just need the Mongo URI. This is the most important. Then we just get a variable for this. Then we call them MongoDB server. So the MongoDB server. Then we pass in the MongoDB URI. But I'll just use say like a connection string so that I think that one is okay. Once we set this up, yeah, I think this one is now okay. So we have our requirements .txt, but I don't know why we are having problems. It's supposed to be so supposed to be backend, supposed to be training. So when that time comes, we just sort that problem. But at the moment, let's now. So on the backend, I have the configuration file. Then we can also set up create a new file under the backend folder. This file will actually contain the memory. Okay? So memory. Then you need to make this folder as a package. So for that reason, I'll create a new file, the init. So underscore init underscore dot. Okay. Once we have that, so I'll just get my first chat memory. So the chat memory file. So chat memory file.py. So this is the one that we're going to work on today. So we're going to see how we can actually create this chat application. No, not chat application, the chat memory itself. So again, so as usual, we're going to first import the dependencies. So I'll import OS, then I will import sys so that we can harmonize our path, so that whenever we are executing this, and we cannot have having that issue that forces us to import modules that do not actually exist. So we just append, so path.append, just append all this. So OS path directory name, OS path directory name, I think this one file. Yeah, this one is okay. Then we start create now the chat memory. So our memory will actually start from here. So I'll start by first importing all the dependencies. So from typing, I'm going to import dictionary. Again, a list will be important for us. Then we also need annotated. Annotated. Again, option. Then from LangGraph, graph. Remember, this chat memory we are going to use LangGraph. So we need to import the dependencies for that. So from LangGraph.graph, graph, we're going to actually import. We're going to import message state, message state, state graph, then start and end, start I'm struggling with my keyboard, but then again from LangGraph, no, this one is LangChain, LangChain. So from LangChain we are going to use code. We are going to say messages. So for the messages we are going to import several. The first one is AI message. Message, my message, system message, and those I'll add another one to this message. This one is okay. Then again from LangChain again, the LLM that we're going to have to be using for this. So again from LangChain, Groq, we're going to import supposed to be chatbots. Yeah. Then from LangChain again. From LangGraph. This one is supposed to be from LangGraph.graph. We're going to graph.message. Just a way to be updating the messages within our graph. We're going to actually import the message state. No, not the message state. We're going to import add message state, add message. Then from date time, then again from .env, then we can just load the environment variables immediately. Let's say, for example, if you didn't add a configuration file, what you can just do is to you can actually get the API keys directly from the environment. Get the API keys from the environment. This is if you didn't create the configuration familiarity. Sometimes this one is very easy. It's short, easy, instead of creating many files. So I'll just Groq API key. Proceed. Let me just ensure that everything is running okay. So Groq API key, where's the API key? Then you can say just if use this conditional statement just to make sure that even if you are missing that key, you're going to raise an error that error so that we actually understand where that error is coming from. Also, we also need just close this camera. Also, another thing that we actually need is the memory check pointer. I think we talked about this yesterday. It's a simple in-memory check pointer. I think you can just import that again from LangGraph. Check the checkpoint memory. Checkpoint memory import there. Checkpoints. We want to import memory saver. Memory saver, but it's supposed to be .LangGraph checkpoints.memory. Then we can initialize it here. Checkpointer. Then you can just initialize the memory saver, this one here. So I think that one is okay. So the next step will be about the state definitions. We'll just create a component here. Then you can state that here we are state definitions. Set definitions for the graph that we are actually creating. So in this one, what about the state definitions? So when we are talking about the state definitions, essentially what we are actually doing, we are declaring some form of a schema, or we are declaring the schema for the conversation, or the memory state, by use of the graph. So our memory is built using the LangGraph. Okay? So think of this as a way of actually shaping up how the memory is going to actually look like. So with this, we're going to let's see what we can include under this. So I'm going to create a class. I'm just going to create a class. The GraphState. So my class GraphState, then we pass in the message state. The message state. Pass in the message state. Okay, no problem. So message state. So let's see. Then so what about the message? So the message annotated. This one's okay, but we need to add, supposed to be first a list, then the base message, then after the base message we add message. And we need this check pointer, so that we have the base message, and from there because we're going to be chatting with our application. So whenever we are chatting with our application, we'll be storing our conversation history as message objects, okay? Then the add message, so the one that we're actually including here, so the add message will actually ensure that the messages are actually handled properly. That means when we're updating our messages and all that, this one will actually help us to achieve that. So whenever we are asking another query, we get a response, we need to update the chat, we need to update the memory itself. Okay? So this one is the one that will actually help us achieve that. Then we have I've introduced the memory window size. Memory window size. Memory window size. Then I just fill this up. Memory window size. Just give me a minute. For the memory windows, there's something. The message, then the memory, the memory window size. I don't know if you're getting me. Just confirm. Let me confirm something. Okay, if my stream is running as expected. It's okay. There's no problem with that. We can just continue. So then for the memory, you can have memory window size. So the memory window size, as this one, I'm just using supposed to be an integer. So int, I'll use 6, but you can use any arbitrary number. So this when we the memory window size, because we don't want to plump the LLM with a lot of messages. So we just want to press a window with our past interactions with the model. So up to the 6th interaction with the model is the one that we're going to be passing onto the LLM, loading into the LLM before we actually give the response. Okay, so it's an adjustable parameter that you can toggle with it whenever you see fit. Okay, then you can have the username. So you can provide the username. So with the username, it can be important in the sense that sometimes you tend to ask why does the LLM actually understand what is my name. Okay, so it can actually call you by your name. So by this, you can actually do that. Then yesterday we talked about the different ways of actually building this chat memory. We saw one thing to do that you can trim the messages. So you maintain the n. So for my case, the n is 6. Okay, so I'm using 6. You can use 10, 20, depending on what suits your case. Okay, so for getting the n message sequence, so you can use that was one of the options that you can actually use. The next option was actually doing a summary. So that's what we're going to actually include. So this is the summary. Again, optional. Okay. Then we can also add the conversation start time. done, we can move on to the next phase, which is about now a response generation service. So response generator service. Just create a new class. So for this one, this is the response generator service. So with the response generator service, this one is okay. So just create a new class here. So class simple response generator service. Response generator service. This one is flat. Okay. So the first thing that we're going to set here is the main LLM, main response LLM. Then we just provide the local limit for this. So this is the LLM that is going to actually get the user input. Then based on that, it's able to actually respond to that. Okay. So let's set it up. So I'll just self-create LLM. So I'll provide this is supposed to be chatbot. I think we imported the chatbot earlier. This is the one that we are actually going. It's supposed to be chatbot or Groq. It's supposed to be chatbot. Okay, yeah, supposed to be chatbot. So chatbot LLM. So with the LLM, so what is it taking in? It's taking in the model. So where are we getting the model? So Groq has, I think Groq has different LLMs that you can actually use. So let's say platform. I think it has various LLMs. Let me see. You can get various, I think these are the models that you can get from, you can see even OpenAI's GPT OSS self-guides 20 billion tokens you can actually get from. So these are the various models that are present in ChatGPT. So you can see for the reasoning models, you have a couple of these. Function calling models, you have a couple of these. QSS, Llama 4 Scout. Then if you have multilingual, you have some of the models, speech to text. Okay, so depending on your task or what you are actually going to use, then I think you can select any of these models to use. But for my case, I'll be using the Llama 3.1 with the 8 billion parameters. So I'm just using this one instant. I'm just using the latest LLM for this. So Groq API key. That's the Groq API key that we're passing in. This one is coming from here. So this is the Groq API key that we are passing here. Then another thing that's going to take, so the temperature and the max token. So for the temperature, I want my model to be a little bit deterministic, so I can the more you move closer to zero, then you make a model to be a little bit more deterministic, not speculate, not speculate so much. Okay? Then for the max token, because this is just a demo, I can just do 50 max. Okay? I don't need tons and tons of sentences. Okay? For generate tokens. Then you can have the helper LLM. So the helper LLM. So this one you can actually call this for summarization. So summarization. For summarization. conversation, you can actually call this, then solve dot, you can call the helper LLM, then you can still pass, the same. So let me see if I'm using the correct LLM llama. So this is okay. We're passing the Groq key max token. You can, let's say, increase this to 75, 100, depending. Or we can do this one. Let's say this 100, then max token, then 75 for this. So that some summary is a little bit the summary of that response. So we don't need a lot. Then for the max token, this one we have sort of okay. Then we can build a prompts that can be used, prompt with history. So the prompt that these models will actually rely on while generating the responses. So we can actually build a function for that. So def build prompts from history. Save. Save. And you can have messages. So message list base. This one is okay. Then we can also, what is the state? So the state is that we need to pass the state. That is now the graph state. Then let me try to do this. What is the self? Messages, the graph state, then you can give a list. I think this will be a list. Channel list. Yeah, this one is okay. Yeah, this one is okay. Then system content. Then we need to provide our prompt, so we are helpful assistant. I can just copy this and set this up. So this is the system prompt that we are passing. So system prompt, you are a helpful, friendly, and concise assistant. So if the states, see, we are passing in the name of the username, so that whatever response that we're going to generate, it can be embedded. It can be, what can I say? It can be embedded within the name, so that it can refer to you personally. So we are passing in our username. Then for this one, I think we have the summary, so that whenever we generate our response, username, so the summary, so it will append the summary of the older conversation, so that older context does not isn't lost. So because we are setting our window size to 6, then let's say that we have reached the 15th interaction. Okay? The 15th interaction. And interaction, I'm saying interaction is your query plus the model's response. Then we are at the 15th. Then the model will only remember up to 15 minus 6, that is 9, up to the last 9 interactions. Okay? But the early interactions, when you are starting that conversation, will be somehow lost. Okay? So to avoid that, what we can be doing is that we can be summarizing each interaction, so that we carry on like a rolling window summary, so that even if you ask something that is not within the last 6 conversation, and through this summary, we are actually able to retrieve whatever we were discussing earlier. Then the conversation that we'll be having, it will seem a little bit natural, or when you is not actually forgetting what you are talking about. Okay? That's the build prompt. Then I can create a new function here. generate response. So self message, then base message, this graph. Then for this one, I just need just a string. Then it will take the prompt as the prompt. Child will give the message as the state. Okay. Then the response that we will be getting from that. So the response again self invoke the response, then we pass in the prompt. Okay? So that before we are able to generate a response, we are able to pass in the prompt. So the prompt is like the guidelines to which you want your response to occur or appear. Okay? Then you can just return the response. Okay? So then that's another method we're going to create is the extract entities. So def extract entities. Extract entities. And you can pass in yourself message list as the base message. No, I don't need this. The self. The string, then dictionary, string, then I can do this. Okay. Extract method extract entities LLM and your person itself. Text string, then there's something close to we have the dictionary. Let's see what we have missed. Yeah, okay. Then we're going to pass in our prompts. So I prepared the prompts earlier. So instead of writing this again, and just put this. So we can just pass it here. So this is our prompt. So this is our prompt. Entities LLM. So extract key entities from this text. Return only a valid JSON file. So it's going to take the text. So look for the name. So if a person's name is actually mentioned, whatever are the preferences, what are the topics that are being discussed, and other relevant information that we actually need. Then we need to return our response in form of a JSON format. So this is the JSON format that we are returning. Okay, so then I'm just using the try except block so that we are actually able to capture errors whenever we capture these errors whenever they appear. Then we need to create another function that is going to summarize whatever we are discussing. So again, that one will involve us adding another prompt. So we can just add all those functions, then I can just explain what is happening. So we are having this function, so summarize conversation. So this is the prompt that, because we are summarizing our messages, so this is what we are going to use. So the prompt, so I've better compress this existing summary with the new conversation context. The existing summary, the new conversation to incorporate. So this is the existing summary. Then we pass in the new conversation that major things within what we're discussing. So we are going to summarize that and add on to our memory, so that whenever we roll down or whenever we keep on discussing issues and whatever, our model is actually able to consider this, summarize, store it for later use. Okay? So once that is done, then compress the summary. Compress the summary under the maximum words for preserving the key information. So focus on keeping user preference. So summarize and also compress it, okay? So that it doesn't necessarily take much of our space. Then the generator, we initialize our class that we created. So whenever we call the generator, will be calling this class. Then, so the next thing will be about the graph nodes. So just pass in the graph nodes. So what about this graph node? So when I talk about the graph node, so this is the individual processing block. Okay. So what it does that remember with the LangGraph, we'll be creating nodes and edges. Okay. So each node receives the graph state and returns a dictionary of state updates. Okay. So these are what I've provided is modular steps. So for the graph for the updates or how we are making those updates. Okay. So we have the memory management node. So this first ensures that conversations that start time is actually set. Okay, we set at this point. Conversation, this one, conversation start time. So it ensures that at what point, what is the start time of this conversation? Okay? Then it looks at the last message. So if the last message is a human message, where is it? So it first looks at the messages. If the last message is a human message, then it calls for us to actually extract entities LLM. So extract entity. So if the last message is user message, then calls our extract entities LLM to actually pull structured information. Let me try to see if let me try to use so that at least whenever I'm explaining this, becomes easily able to follow through what I'm doing. So I'm just going to use this sketchpad. Definitely just use Python. So I think up to now we have actually used these LLMs, ChatGPT and the rest. So for example, let's say that this is a user, this is your message, then this is the LLM's response. And then let's say this is your monitor, this is the user, this is the response coming from the LLM. Okay. So once you ask the user, then the LLM will generate the response. But when you're working with when you're working with the graph nodes, then what it means is that first we ensure the conversion start time is set. I think that was this time. Okay? Then we are looking for the last message. So if the last message is for a human message, then we call the LLM, we call the extract entities LLM to actually pull the structured information, e.g. the name, stories, and stores it in the given state. Okay? Then it also enforces the update. It also enforces or updates the memory. So we need to update the memory based on that, so that we're able to get to the latest information. Then once that is done, we can then pass in the summarized node state. So let's pass it summarized node state. There's another format actually summarize the node state. So once we summarize this, so if it is longer than the rolling window k, remember k is our 6. So this one that's our the rolling window. So if it is longer than the rolling window k6, it takes the older messages, everything except the most recent k. Then you'll be able to call the generator to summarize conversation. So generate this one. We're calling this function so that we're able to create an updated summary. Okay. Then once we have that, we then compress that summary, and then we're able to return the update. So state summary, return this one, return state summary. Where is it? We're able to return so this one we are compressing. Then we're able to return the compressed summary. Okay. If not enough messages, it returns nothing. So summarization won't be done if you haven't really, you're not really chatting with the model itself. Okay. Then we can add another method. So this is the last one under this, and this one will be for this one. What you're doing with this LLM node state graph. Okay. So with this one, you're able to build the current LLM context. This one. So what you're doing with this one is that you're able to build the current LLM context using the rolling window of recent messages as the optionals, as the summary that we have provided previously. Okay. So we're able to call the function called generate response. This one. So generate response. Then we pass in the recent messages and what's the current state. Okay. So we are doing this so that we're able to get the assistant to reply. Then once we're done with that, we can wrap the reply as an AI message, so that we are passing that one as an AI, so that the response is considered as the AI message. Then yours is just the query. Okay. So that the app appends it into the conversation. So the response that you're getting from the model itself, you need to denote or assign it so that you're making sure that that one is coming, that one is an AI message. I think we previously were able to import those. We were able to import AI message and the human message. System message is all about the prompt that you're passing in. So that's the system message. So having this, we are able to differentiate like what is the AI message response, what is the human query that we're also passing to. Okay? So once we're done with that, we need to now move on and actually define the graph workflow. We're going to define the graph workflow as it's based on what we have done so far. So the graph workflow. So workflow. So how is information moving within our graph? Okay? Then this is the state graph. And we can just pass in the graph state. We can pass it with that. Then workflow. We are going to add some nodes in this workflow. So workflow add node. So the memory management node. Then we can also add another node, the summarization. Summarizer. I think it is summarizer. Summarizer, I think that so summarizer, then summarization. Summarizer node. So this is summarization node. Then the workflow. So we can add another node. So there's the LLM node. Then we need to add some edges. So we can add the memory management edge. So but we need to actually define this is the start of this. So we can start, then I can just go with this. Then start, we can start with the memory manager. The memory manager. Then another edge is the now this one comes we need to pass it. as the next page. So memory manager, then from here we get to the summarizer. I think this one is okay. Then from the summarizer, then LLM. Then from the LLM, then this is the end of this. So this is not H, supposed to be the end. Okay. So start memory manager. Then from the memory manager to summarizer. And from the summarizer is the LLM. Then LLM end. Okay. Then we can compile our application. So compile the application with checkpointer. With the checkpointer, so that we have this is the workflow. So workflow dot compile. Then we can pass in the checkpointer. Passing the checkpointer, checkpointer, this one. Because checkpointer, okay. We are passing in the checkpointer. We initialize our checkpointer somewhere. This one. Where is the checkpointer? We initialize our checkpointer this one here. So once we pass in the compile the app checkpointer, then we can okay, I wanted to print the GraphState, but I don't like the format of how it's actually appearing. Then you can come up with a test. So a test, so test function to test. And come up with a test function. So test. Test function, so that we can test to see how our memory is actually performing. So this one is just about whatever we have done today is just about initializing the chat memory itself. Okay? So that is the main objective that we are solving for today. Once we solve for that, we can add. This one is for a single. Let's say this one is for a single user. But if you have multiple users concurrently using your how can you build this to also serve multiple users? Okay? And you can integrate that so that then we can do a memory integration so that we can link this, make sure that it's able to work better when we are having multiple users. Then maybe further down the line we can actually build the front end so that we're able to create new messages, delete messages, things to do with that. Okay. So then I'll just create a function. For this function, we are going to test the conversation. So we are going to test the conversation. So I just think I did this. What I'll just do is the conversation. Then, okay. So we are first initializing the memory system. Then the application, this one, that we compile our application into this so that we can just call it easily. Then we are passing in the config that the thread. So I think we're getting the thread ID. So that we're able to separate conversation using the thread ID. This one will be important downstream when we use our application with multiple users. And how do we note that this conversation belongs to this individual? Then because we have a user and we have this thread ID, it will be very easier for us to actually note this conversation belongs to certain individual. Okay. Then once we have this, we can then pass in the if. Then main. Then so what we can do, just use a print statement. With the print statement, we can say testing. use the try block so that I can set this conversation, and you can just pass in the except. So print error, just failed. Then what I can do, I can just import the test pack. I can just import the test pack, then you can print test pack.print there. Once, so from here, we need to actually set our environment variables. So let me set my environment variables. Okay, so once you have set your environment variables, remember the environment variables that we're using is the MongoDB URI, the MongoDB database name, and the Groq API key. Okay? Once you have those, you can just supply those within your .env. Let me probably what we can do, because I didn't want to share my details. If I can just create, let me create, if you create a new file just specify what you're going to pass here. So you're going to pass here your MongoDB, your MongoDB URI, your MongoDB URI, then your MongoDB database name, then your Groq API key. So those are the things that you just need to initialize within your environment. So once we have done that, we can just set this. Set this. Then we can now run this. So I just run Python, just copy the relative path and just so some things that we did not finish doing. So what we can do, we can just do a pip install of all these at once. Let me find a way to do that. So what I can do is pip install. Just install all this. Okay, so let's say Python, then we can run import message state. states. Graph. Why now? Let me see. Messages state. Supposed to be messages state. Okay, message state. Okay, try once again. Let's say CLS. And let's try it once more. Yeah, there's another problem. Supposed to be add messages. What are we doing? Add messages. Message states. Okay. Now this is the problem of running code. Oops, I did not save the debugging process. It's 10 years. Okay. Class graph state. Class messages state. CLS. Was part of writing code. I did not save. I need to. Where is the autosave? Yeah, I need to have the autosave on. Add message. Messages. You need to save it. Sometimes things are. You're having an error. Yep, I think now you're getting the response that you wanted. So luckily you're also getting the graph structure. So this is the graph structure. So you can see stats. manager. Then from the memory manager, we are moving to the summarizer. And from the summarizer, that is the LLM, then the end. Then we are starting our chat memory. So remember the graph memory that we did set previously. So then we're starting our conversation steps. So turn 1, hi there, so, memory extraction. Remember, this is the first interaction with our chat application. Okay, we don't have any stored memory and all that. Okay, so this is a memory extraction. Then this is the summarization. No summaries needed yet. So the LLM processing using the rolling window for the last one message. So you can see this is the first interaction. So this is the first message. Okay, then the LLM response generated maximum of 50 tokens. We don't want to exceed that. So hello, how can I assist you today? So this is the reply from the LLM. The memory state, username is not set, summary, no summary set yet because okay, how can I assist you today? It's not something that you want to be stored within your summary. Okay? So this is the turn 2. My name is Alex and I love hiking and reading sci-fi books. So the extracted entities, so the name is extracted as Alex. Then there is a preference also extracted from that, so that is hiking, and also the reading of the sci-fi books. So we're able to actually extract that. Then extracted and said name username as Alex. Okay. Then the summarization, no summaries yet. Okay. Then using the rolling in for the last 3 messages. So LLM response generated. So AI, so nice to meet you, Alex. It sounds like you enjoy the great outdoors and exploring the new worlds through fiction. Have you got a favorite sci-fi book or author that you always come back to? So the memory state, user is Alex. You have noted that summary will be no summary yet. So user, will you recommend for a beginner hiker? So what would you recommend? So this is the user asking a question. Then you extract that. So then preferences. See, this is the preferences. Non-user is still Alex. Okay, other information. Again, no summary yet. Maybe we haven't. Maybe up to now we haven't got anything outside that we can actually do a summary of. Okay, so I think it's the response. Okay, so I think we have actually built it, and we are seeing it actually working in operation. Despite the 1-2 challenges that we're having, I think right now we have actually built the chat memory itself, and we have seen how the system is working, how we are summarizing, and how we are extracting entities from that. So the longer you proceed with this chat, then I think this summary will now come when you actually in a longer conversation. I think you can actually summarize. This is just a shorter conversation because there's still some things that we need to cover. There's still some. I think this is the chat manager that we're able to delete chats. Okay? The integration part of it. This one is just purely for a single user. What about if you have multiple users? We are going to find how we can actually integrate that downstream. So I think that's it for me today. I think it was a wonderful experience about building chat application, chat memory, and we have seen how we can actually ensure that when we build these applications, we can integrate memory, so that whenever we work with this memory, we are building applications that can actually resonate with us. So that's it from me today. Maybe the next time we'll be incorporating another element for this until when we actually build the backend as well as the front end, where the front end interface where we can see our chat applications. So that's it from me today. If you're new to this, please consider subscribing and on the notification bell so that whenever you are getting such content, you're notified promptly. You can also comment, share your opinions, ideas about this. Then I will see where we can